Hello there, Jay here from Jay's Vintage Junk, and this is attempt number 2 at making this video, unfortunately. We're back working on that French record player, the voix de maître, I believe that's how you pronounce it. It's basically French for his master's voice. I've just done a brilliant, about an hour and a half long video on basically rebuilding this amplifier, and I went up to the computer to edit it all up and get it ready to go on YouTube, and my memory card won't read. This is the second time actually I've had issues. I got a couple of memory cards with this camera when I bought it, and they were fine for the first few videos I used them on and stuff, and then one of them cards became corrupted and it wouldn't read properly and keep giving me errors, so I binned it and I just carried on with the other 2 cards that I had. Now the other one that I got with that camera has obviously died a death. It won't read, it won't recognise or anything. So basically what I'm going to have to do for you, we'll get the camera reset up back down on the bench here, and I'll go through basically everything I've done with this amplifier, and then we'll get on to the part 2, which is what this video would have been if that video would have actually worked, which is we got to the point on this where everything had been replaced that needed to be replaced, and we was just getting ready to test it. But like I said, the video was already about an hour and a half long, so I said I'd do that in a next video. So what we'll do is we'll recap what I did in the lost footage, and then we'll actually get on to what we're meant to be doing in this video, which is doing some tests on this now it's been rebuilt, putting the valves in, because obviously the power supply section in this is untested yet. Last time we powered this up we did it using my bench HT power supply, to ascertain that the whole thing actually worked. We've now got the new transformer in there, new capacitors and what have you. I've had to do a few little alterations to the power supply circuit a little bit, just because we're using a different transformer and it's slightly different configuration. Anyway, so I'll get the camera reset down on here, we'll go through that, and like I said, and then we'll get on to doing some testing. So back in a sec. Right, okay, that's better. At least you can see what's going on now. So as you can see, we've got the transformer that my mate Steve let me have. That's nicely mounted down there. All we had to do, it fit already. It's actually very, very slightly smaller in physical dimensions than the original. Not by very much, but a little bit, if you can see there. It's about 8mm or something like that, and again that way, a couple of mil, about 6mm that way. So it is a very slightly smaller transformer. Obviously this is, like I said, this is a modern build transformer, different laminations and everything. So we had to drill 4 new holes to actually mount it down, and what I ended up doing was using the 2 screws that came with this transformer, because I believe it was mounted that way on like that, and 2 of the original studs that came with the original transformer, and it mounted in really, really nicely. Like I say, it's really solid. It's I'm quite pleased with how that went in. And then we proceeded to, let me see if I can just find something I can stand this up with. That multimeter would work. Yeah, that kind of holds it the way I want it. Let me get you zoomed in a little bit now. There we go, that's better. This is the bit we want to concentrate on first anyway. Right, so as you remember, if you've seen the previous video on this, you'll know that basically what I believe happened to this record player, this was 115 or 220 volt switchable, being a Continental record player, and I think it got switched to 115, 120 volts and then got plugged into 240 volts mains, because the smoothing capacitor there had actually exploded and spewed its guts everywhere, and the mains transformer obviously was open circuit, that had an open circuit primary on it. So I think that's basically what had happened to it. So we've put that substitute transformer in there. Now the HT output on this transformer is somewhat different to the original there, so we've had to do a few little adjustments. That is actually a double centre tapped transformer, so you've got HT as 0 volts and another HT winding which go off to your rectifier. The 0 volts goes off to ground. I've had to just use one winding on here because this would give far too much HT out for this circuit if I used it in that configuration. I've just used one of the windings off it and wired it that way. So I've basically got 190 volts AC on my HT secondary there. Apart from that, we had some fun when we was just wanted to make sure that that was actually working. We connected some wires up to it and then powered it up, and I wasn't getting anything out of it. I'm thinking, why am I not getting anything out of this? Then realised I hadn't put the strap in to link the two windings together in the primary. I wired that up, but I wired it up wrong. Fortunately, I've got my safety lamp actually connected up while we was testing. I actually managed to wire both 120 volt windings in parallel instead of in series. Like I said, fortunately I was running on the safety lamp and it didn't cause any problems. I then rewired it correctly. So we've got basically the 220 volt primary windings are wired in series there. That comes across obviously, and then we've got our HT out there to our rectifier. We've got our heater windings there. I changed the blown 32 UF capacitor there. This one's rated at about 450 volts with that's actually a salvaged one off a switch mode power supply, but it's 33 UF at 450 volts, so it's pretty decent. It fits nicely in the space that one did, and like I said, I managed to make it look really quite neat and tidy. Next we took our attention over here. We did actually have one burnt resistor here, which is down there. I don't know if you can just make it out. It's that one in there. That's actually on the negative of the HT capacitor. It's only a small value resistor to ground. Now, it was smoked. It was very, very burnt. And I did actually first take a meter reading off it, and it come out as about 35 ohms, something like that, which I thought was a little bit high. Now I estimated that it was probably meant to be something around 22 ohms, something like that. Fortunately, when I actually got it out of circuit and cut it out, I thought it was completely illegible on the top. On the bottom of the resistor, you could still actually make out the colour code, and it's 10 ohms. So I put a new 10 ohm resistor in there. We replaced those two capacitors there. Again, these are no better than the old wax paper capacitors in the UK, or the Hunt's mould seal capacitors. These go just as leaky. These are basically the French equivalent. Like I said, they go just as bad, these, just as leaky. Those are in the tone correction circuit, so a little bit of leakage in there. It wouldn't cause any major issues, but as I want to go through this amplifier completely, I just replace those with modern equivalents. Right, apart from that, really, we'll move over onto the other part of the amplifier. And again, this was exactly the same as that. We did check the resistors. All the resistors I found, all the resistors I've checked are absolutely banging spec. There was a few capacitors here we changed out. We changed at 50 UF there, because that's basically completely dried up. It's just nothing, basically. It's just open circuit. I'm not getting any reading on it at all. No capacitance, no resistance or anything, so that's just dead. So I replaced that with that nice nice one there. What makes that one? It's quite a decent make one as well. Yeah, it's a reefer. I had a few of these in my box, so I thought I'd stick one of those in. We replaced the little, I think it's cathode bypass capacitor there, a little 10 UF. That was actually still reading okay, but seeing I was changing all the other capacitors, I thought it's silly to leave it in. So we did just replace that. I think that's about it. Oh, there was one capacitor, I can't remember which one it was now. And I couldn't actually read the value on it. It was so degraded, I couldn't actually read the value on it. Fortunately, it did still actually read as a capacitor, and I was able to use my my capacitance checker there to actually read its value. And if you can hear, you missed the hilarious moment where this jumped off the desk as I was trying to test the capacitor and smashed on the floor, and at least losing that you didn't hear me swearing. It's just the battery's fallen out inside it. I just need to crack it open and put the battery back in. But basically that's where we're at. So yeah, that's literally exactly where we're at now. Let me get you zoom back out again. So what we want to do now basically is start our testing. So what we will do, we'll get that so it's reasonably safe. I need something I could just sit on there so it doesn't keep rocking back like that while we're working up. That's what I had this drill battery here for, wasn't it? Yes, there. Perfect. Right. Now, what we need, I've got my lamp limiter here. We'll see if we can get that into shot as well, because this is very useful when you're doing like initial testing. So we'll get that in shot. We'll connect it up to that. We've got my safe block here, and like I said, this, we've not done anything with the switching arrangement or anything for now, because you know that'll come later when we start putting a mains lead and things like that on this. For the moment I've just got two bare wires coming off the transformer, off the primaries of the transformer. So these basically are going to go to the safe block so we can energise the transformer, and then we can test some voltages. So we've currently got no valves in at all. All we want to do is ascertain that we're getting something sensible coming out of that transformer there. So we will, and we are going through the safety lamp just in case there's something silly, because like I said, as I was doing the initial testing when I was doing the video which we've lost, I had made a mistake, and this saved us damaging that transformer. I was rather tired while I was doing it, which I don't recommend doing, is working on this stuff when you're in the least bit tired. Right, okay, we will pull the test meter in. Let's get that there so you can all see it. Hopefully you can see the display on that. And we will set that to AC. Right, we should have 190 volts coming out of that tap in there. So the 200 volts range on there should be fine. I'm set to, oh, that's stupid me, that's 200 volts DC, we should be over here. 200 volts AC. We will connect up the test leads to the transformer like that, and we should get around about the 190 volts mark. It might be slightly lower because we are running through the safety lamp. Well, sorry about that folks, battery died, but never mind, we'll carry on. Hopefully this is still recording. I'm certainly having camera issues at the moment. Anyway, I'll switch that back off because I just realised, right, where we're at to. We're all connected up onto the secondary, the high tension secondary there. Got a meter here, so if I switch on, you'll see we've got about 193, 194 volts there. Like I said, that's running through the safety lamp, so what I'll actually do is I'll switch that over onto the 600 volt scale. We've got 195 volts, 194, 195 volts there. I'll switch the lamp out, and we've got about 200 volts AC, which is pretty good. I'm quite happy with that. That should give us enough rectified HT to be able to drive this circuit quite nicely. Right, we'll switch that back in. We'll turn off. We'll disconnect from the transformer there. And what we will do, let's just, for absolute safety, we'll open the safe block like that. And what I want to do first, I will put the a rectifier valve in, and we'll just fire it up and see what our HT actually is going to be. Now this is not going to have any load on it really, because we're going to put the other valves in, so it will be a little bit higher than it will be when the whole circuit's working properly, but it'll give us an idea, are we in the right ballpark or not, basically. Let me see if I can find what I've done with those valves. I'll put them somewhere safe. Ah, there they are. Right. Okay, which one are you? What's that? It's a 12AX7, that's not out of this. There's the output valve there. There's our preamp valve. And there's our rectifier valve. So we'll put the rectifier in. Okay. And put its little retainer on. See, I'm going to be mucking about with it. I'll keep it nice and safe. Flip that back over. I have to be a bit careful because it is basically resting on the top of the valve there, so we do have to be a little bit careful here. Right, now what we want to do, let's get this, let's have it on the 600 volt scale, because I'm pretty sure we're going to be a little bit over 200 volts. It'd be nice to be around unloaded, so we're just running the rectifier here. I'd be happy we've got something between, say, like 230, 250, something around there should be about right. That should come down possibly a little bit once we get the other valves in. Right, we can clip that to ground, and we'll clip this to somewhere. I don't want to clip it on there because it's a little bit, I might be able to get it on there safely, let's see. Because what I don't want to do is get it to short onto another pin where it's not wanted. That's reasonably safe there. Yeah, I'm happy with that. That's going to be okay on there. I'll get that so you can see it. Right, so what I'll do, I'll energise this again. We've still got the lamp limiter in, good. Obviously it won't come up straight away because we'll have to wait for the valve to warm up before it starts emitting. But this should give us an idea whether our HT is actually going to be okay or not. So we'll switch on there. We'll shut the our pilot light does illuminate. And we'll watch on here and we'll see if we get some HT coming through as that valve warms up. Not getting anything yet. Now it could be that valve got damaged when this record player had an over voltage. There is a chance that valve had actually been damaged, because I expect to be seeing some HT coming on here at this point. Yeah, there's nothing there, so we'll switch off again. We'll unplug that. I think the meter is fine. We should be getting a decent enough ground there. So what we'll do, we might even try getting a contact over there for the a reading, because that's a good place to take it there actually. Right, I might just try a different valve though. I was wondering about, I mean it lights up, the filament's still good in it, but I think that might have taken a bit of a beating, like I said, when this thing had an overvolt on it. I'm pretty sure that's what happened to it anyway. I think I've got another EZ80 in here. Let's have a look. Yes. Let's try this. Okay. This is a Mullard, British, made in England. So that should be good. Right, that's okay. Let's connect the meter back up. So we need to get, in fact, let's choose one of them for the ground. That's a decent ground there. And let's see if we might be better off. Now that's got the HT on it, isn't it? Yes. We should be able to pick the HT up there. That should be okay. Let's get that so you can all see it. Right, let's try again and see with that different valve whether that makes any improvement. Right, I'll switch on there. Let's shut the thing. The new valve is indeed glowing. It will take, obviously, it'll take a little bit of time to there we go. We've got HT 256. Ooh. That's not too, that's a bit high. Like I said, that's a little bit higher than I was first hoping. We've got 264 volts HT there. Like I said, I was 250 would have been nice, but that has not got really any load on it. Like I said, we've not got the output valve in, which obviously will load it down quite a bit. We don't even have the preamp valve in. All we're doing is running the rectifier to make sure we've got HT there, so that should come down quite nicely and we should be somewhere within ballpark. Right, I think the next thing to do now then is we'll switch that off again. We'll put some, get that out of the way for now, just while we're connecting up. We'll put the other two valves in and we'll connect a speaker up and we'll see if we get anything anything out of it. And that's the output valve in that socket, I think. Yeah, it should be, because the other one's a different base. Okay, so that's our output valve in. We'll put our preamp valve in. Alright, turn this back over. Actually, we've got to be rather careful with it now. Oops, I have to be rather careful with it now because the valves are in, and at least having it this way around, they're not resting actually on the table because I don't want to risk stressing or damaging a valve. Right, we'll put that over there because that's, we can get that out of the way now. Let's get the meter connector back up so we can monitor the HT. That's our audio input there. We'll put that to one side. We'll get this connected back up so we can monitor our HT. We'll connect that onto there like that. We'll connect that onto one of them bolts again because that was a nice ground. That's a point as well. Yeah, that shows that capacitor. Them capacitors are all still charged as well, so you do have to be careful working on something like this, because obviously you do have these capacitors hold a charge for quite some time. There's no bleed resistor on old equipment like this. Right, that's okay. What we do need to do is hook a speaker up, because it's not really good running the output valve without a speaker connected. I've got a test lead here. We grab another test lead and we can lash those speakers up. That's not going to work. Sorry, I'm completely covering the camera, which is really unprofessional, I know. What have we got here test lead wise? Come on, test leads. Oh, that's not a very good test lead, but it'll do for a speaker. Oh, that's a bugger, that's just broken. Right, I've got half a test lead. I suppose what I could do actually, because I've got half a test lead. I've got 2 half test leads, haven't I? Because where they've been soldered together just snapped. Right, let's try this. I've got our speaker connections there. Twist that onto there. We'll twist that one onto there. And we can connect our test speaker up. Right, there we go. That's our test speaker connected up. So we've got some load on the amplifier. There we go, that's all connected up. We are ready to give it a basic first test, I think, and see if we actually everything looks okay and we actually get some audio possibly out of it. So I'll close the we have got volume control there and we have got our tone control there, so we can test those. Right, excellent. I'll put power back to it and we'll see the HT climb back up, but hopefully it shouldn't climb up quite as high. We've still got the safety lamp in series, so we can always turn that out when we're happy that nothing's going to actually catch fire or anything. So we'll switch on. So the safety lamp lit ever so slightly there, because we're actually drawing some load now. And see our HT's coming up. I'd like it to be a little bit higher than that, really. That's a little on the low side. Although we've got something there. Quite a lot of something there. We've got a fair bit of volume there. That's all the way up. That's not too bad, that. What we can do is we can switch the lamp limiter out so it's getting the full mains voltage. The HT should come up a little bit, and we'll see what that's like, but that's not bad. That's not bad at all. So we'll knock that out of circuit. There we go. Did you see that instantly jump up to more where I want it? don't have significantly more volume, but a little bit. There's plenty there for what we want to actually be driven by the stylus. That's absolutely fine. I'd like it a tiny little bit higher than it is, but it's enough. I'd really like it around 200 and say 220, 210, somewhere around there, but we've got 190. We could change the configuration on the... What we'll do basically is we'll see how it goes like this. We could change the configuration on the transformer, use both both tap-ins on the HT secondary winding, but I think that'll give us far too much high tension, so we basically have to put some kind of drop-in resistor in to bring it down to something a little bit more sensible. The way it's working at the moment, the valves are actually getting enough high HT, obviously, because otherwise we would not be getting that kind of output from it. Let's see if the tone control works. Yeah, our tone control is indeed working. I'll tell you what I'll do. Obviously is going to need a little bit of work on that pot. That's a little bit scratchy. But yeah, I will have to see what I can do with... Let me just switch off now. I will actually have to see... Oh, look at that. That's better. It's dropped right down now because we've actually got some load on the circuit. It's not a standard... Let me get you down a little bit so you can see it. That is not a standard potentiometer. It's actually got a centre tapping on it, which is what this capacitor and this resistor is connected to. I could eliminate that, and the amplifier would still work, but it wouldn't sound quite as good as it does now. It's some part of the negative feedback circuit for the output valve. Like I say, it could be eliminated, but obviously the amplifier wouldn't sound as good as it does with it. So I'm hopeful we can basically clean that pot up anyway, a bit of switch cleaner in it and work it back and forwards, and hopefully it'll come back. So what I'll do now, I might actually give that a quick blast now. I've got some here on, so yeah, with our HTs nicely down to nothing, we'll disconnect for safety. I think I might just have enough. I've got some service oil left here. I'm just a tiny little bit. I really need to buy some more. Let's see if we can get some of that in there. And we'll give the controller good working backwards and forwards. There we go. Right, like I say, I'll get this flipped back round, and we'll get the computer connected up to it, and we'll see how it plays with some music playing through it. So I'll say back in a sec. Right, we're all set up and ready. As you can see, I've cleared the bench off a little bit. I've got my laptop booted up here. I'm using the same setup as I used last time we got this amplifier powered up. So basically what I've got is a little isolation transformer here. So we've got the audio coming out of the laptop. It's monoed up. It then goes through a little isolation transformer there. And then I've got a way here obviously to come out and connect it into the so connect it into the actual record player. So I think if I'm right, that should be correct. Connect that up to there, connect it up to there. They may have to be swapped over, we'll see. I'm going to actually use the same, well, I'm going to start off with some music that I played on the last one of these. This is 4-hour cyberpunk dark synth mix. This is White Bat Audio. What I'll do is I'll leave a link in the description of any of the music that I use. Like I said, this is all royalty free music which we can actually use on YouTube and not get a copyright strike for. So it is, obviously, you do want to promote the people that are doing it, and it's not bad actual background music, to be fair. Right, let's switch on. Like I said, I've simplified this so much. I've got rid of the lamp limiter because I was quite happy that everything was okay, and I've got rid of the meters and everything. But we are still on the save block to energise it, so I will energise the save. Oh, it helps if I plug the save block back in, doesn't it? We plug the safe block in, and that should bring the amplifier on, which it does. As you can see, we've got our pilot lamp on there. Our valve heaters should be lighting. I will switch the amplifier on, but only a little bit. I will start the computer playing. Come on, computer. And of course, as immediately I start to do that, the computer starts to act up and not want to play. Come on, you stupid computer. Yes, lovely. Opera not responding. Fantastic. Just bear with me a second, folks. I'll come back as soon as I've got the computer to behave itself. And of course, as soon as I said that, the computer started to work again. So right, let's crack on. I'll start the music. Now it says runs through a little bit, and let's increase some volume. There we go. Still need to spray that pot. I haven't sprayed that one. But the volume control, which was crackly before, we'll listen. No crackle at all. Tone works perfectly. Apart from the crackle, the tone works really nice. So the capacitor replacements work. Let's try something else, shall we? Something a bit more classical. So I'm sure an amplifier like this was never designed to play this kind of music. Right, let's see what else we can get up quickly. If the computer's going to behave, that is. Right, here we go. Let's see what we've got here. I was trying to find something classical rather than there's a lot of synth, chill music, stuff like that, but like I say, I've got some instrumental background music here for videos and vlogs. And this is from royalty-free music, no copyright music. Again, I'll leave a link in the description of the I'll leave a link in the description of the video to this. There we go. The artist of this is Bryant, I think. The track's called Places. It's about as loud as it will go, but that's absolutely fine. Pretty good. It will actually sound even better when it's in its cabinet, because just using a speaker like that just sat on the bench is not going to give it the best. You actually need a cabinet for a speaker, really, and to be able to get what we're getting out of it like that means it's running pretty well. transformers are stone cold. That's just aired. Rectifier should be quite warm. Not that warm, I can keep my fingers on it. And the output valve should be reasonably hot. I can't keep my fingers on the output valve, but it's not burning hot. It's absolutely fine. So I think I would call that a fairly good repair of that amplifier. We'll just shut off now. And we'll disconnect it. Because obviously this is not safe. This is literally just a way of powering it up on the bench. Obviously this is all going to get changed when it actually gets installed back in the record player. But I am really quite pleased with that, considering the amount of damage that had been done to this. Like I said, burnt out mains transformer. It's come out quite well. I am quite pleased with that. It sounds pretty decent for what it is. For a single-ended basic amplifier like that, it does actually sound pretty decent. So I suppose the next thing, and this will be the next video on this unit, we've got to tackle that thing. I've never ever worked on one of these before. This is going to be a challenge, getting this record player, this turntable, to actually play records again. It is fiendishly complicated on the back. It is not like any other record player I have ever worked on. We've got a very interesting motor here that we're going to have to look at that uses these motor start capacitors to actually start it. That's got multiple windings. There's at least 4 windings on that motor there. The bushings that the motor actually glides on have gone. They've completely disintegrated. All the rubber parts on the back of this turntable have basically gone. They've turned to mush and just disintegrated. Every single one of them should be one there, one there. All these rods should have bushes on sides of them, and they've just crumbled away over the years, so we're going to have to do something about all those. Amazingly, the mat itself, which you'd expect to have done the same thing, is in absolutely perfect condition. It's in amazing condition. But all the rest of the issues with it. So the next time we're going to do anything with this record player, I do want to do some computer related things for a few videos, I think. But next time we get back onto this record player, and I think this will probably be the next, the next time you see me messing with a record player, it's probably going to be this one. We're going to attack this deck and see what we can do with that. Once we've got that working, or indeed if we can't get it working, we can find something we can substitute it for. We can actually start putting this record player back together and make it into something pretty decent, I think. Because that cabinet is fantastic. The cabinet is in such nice condition. This sounds great. It's better than your standard dance set amp, put it that way. It's leaps and bounds ahead of what you'd find in a British dance set. So it's all down to seeing what we can do with that. Anyway, I'm going to leave it there for now. I hope you enjoyed this little video and update on the project. I'm just apologise profusely that you didn't get to see me spend an hour and a half rebuilding the actual amplifier. But it's nothing you haven't seen me do before. It's just a case of taking capacitors out, finding values, putting the new components back in. You didn't miss anything that you haven't seen me do in the past. I'm just a bit annoyed, like I said. I'm going to have to save some money up and buy myself some new compact flash cards. Not compact, compact media, whatever they are. These things. That camera will only take 32 gig, I think, maximum. So it's trying to find some which are decent and aren't fakes or anything, which are actually going to work for me. So anyway, I'm going to leave it there for now, because I hope you enjoyed this little video. So I will say thanks for watching and goodbye.